Hello everybody and welcome. So here we have three limits that I want to take a look at. This video will not include the background information that was in the previous video about this. We're just going to quickly go through these three limits. Here we got this first one, and we got a second one here, and we have a third one over here. Okay, and each one has something a little bit different about them. So in all of these we have polynomials being divided. The degree of the numerator here is 4, the degree of the denominator is 6. Scan each term, see which one's the biggest. And so, for this one, just like before, the degree of the denominator is greater than the degree of the numerator. Okay, so that means the bottom is going to grow faster than the top. And if the bottom grows faster than the top, if you divide by a giant number, 1 over that number is going to get closer and closer to 0, okay? So if this is a multiple choice question, without doing any work at all, you immediately know it's 0. Okay. Now, if it's a free response question, you have to be able to justify this. Okay. And the way that we do it is the same in every problem. We factor out the highest power of x in the denominator. This is basically like rescaling the problem according to the degree of the denominator. That's what we're doing. And so the highest power in the denominator is x to the 6. So what I'm going to do is I'm going to factor x to the 6 from the top and the bottom, and I'm going to see what's left. If I factor x to the 6 from the top, well, let's look here. I had 4x's, I took 6 away. That means I need to divide by 2 factors of x. So I get 3 over x to the power 2. And again, the reason is because if I distribute, okay, let me go to a different layer here. If I distribute, then x to the 6 over x squared gives me x to the 4th. Okay? So that's why this works. Okay? So let's continue. If I factor x to the 6 from x squared, I need to divide by, I need to divide by 5 layers, or 5, hold on. Let me regain my thoughts here. I'm factoring x to the 6 from x squared, so I need to divide by 4 factors of x. Plus 7 over. I had 1, I'm taking 6 away, that means I gotta divide by 5 of them. And then minus 10 over x to the power 6. Okay? Over. And now, again, I've already taken x to the 6 out. If I take x to the 6 out from 5x to the 6, I'm left with just 5. Minus, this will be 6 over x, plus, this will be 10 over x to the 3. Okay? Because, again, we're distributing in reverse, right? And I made a little mistake. This should be x squared. Sorry about that. Minus, if I take 6 factors from 2, I need to divide by 4 of them. So 36 over x to the power 4 plus 100 over x to the power 5. And then finally, there's no x's. I got to divide by 6 of them. Woo! All right. So it looks, big and nasty, but it's about to get a lot simpler. So here we go. Limit x approaches negative infinity. X to the 6 over itself, that's 1. All I'm left with is what's in this big parenthesis here. And before we continue, let's write down this one fact that we're going to use over and over again. And in AP Calculus, you may use this. Okay? It doesn't matter if it's plus or minus infinity. Either one is fine. 1 over x to any number where r is positive, okay? R has to be positive. As long as r is positive and x is in the denominator, this limit is going to be 0. Okay? Because x is getting really huge, and then if you raise that to some power, even if it is even if it's like a 1/2, like a square root or something, it's still growing. It's still going to grow forever. And 1 over an infinitely large number is going to be tending towards 0. Okay, so this is what we're going to use. Let's use that over and over and over again here. Okay, so again, x to the 6 over itself is 1. And now let's look here. Here, this is like 3 times 1 over x to the r. Here r is 2. And that's definitely bigger than 0. So as x goes to negative infinity, we're going to be dividing by an infinitely large number. So this is going to go to 0. And it's the same situation for all of these. This power is even bigger in the denominator, so the denominator is going to grow even faster. So it's going to go to 0 even faster. Same thing for this one. Same thing for this one. So we get all zeros in the top. And now let's think about the bottom, right? So we have this 5 left over. But now look at this, right? Same thing. 1 over x to some power. X goes to plus or minus infinity. We're going to 0. Same thing here. Same thing here. Same thing here. Same thing here, right? 0 everywhere except for the 5. So we basically just get 0 divided by 5. And of course, 0 divided by 5 is 0. So this is how we show it. Just like this. Okay? That's it for that problem. Let's move on to the next one. Okay? So here we go. The degree of the highest power in the numerator is 8. The highest power in the denominator is 9. And you know what? I didn't mean to do that. So we're going to change that because that's not the point of the lesson right now. We already did this. So I'm just going to change this 8 to a 10. Okay. So now everything is looking good. Okay. So in this problem, after I changed it, the degree of the numerator is greater. The degree of the numerator is greater than the degree of the denominator. Okay. So that means that the numerator grows faster than the denominator for large x values. Large positive or negative x values. Okay? Good. So if the numerator is going to grow faster, that means the numerator is going to be bigger. And if the numerator is bigger than the denominator, then the number itself, the value, the ratio, is going to be larger. And so we can expect, since the top is growing faster than the bottom, we can expect this to be for the moment. It's either gonna it's going to be positive infinity. Okay, just by looking. So again, if this is multiple choice, and positive infinity is an answer, there you go. You may see this as an answer as well, D and E. Because remember, infinity is not a real number. Okay. So again, multiple choice. You don't have to do any work. There it is. Degree of the numerator is higher. There's your answer. But if it's a free response, then we have to justify, right? So we do it the same exact way we did this one. Same exact way. We're going to rescale according to the denominator. Highest power in the denominator is x to the 9. I'm going to factor x to the 9 from the top and the bottom, both. Okay? This will leave me with 10,000. And then I fact, 10 minus 9, right? I have x to the power 1 left. Minus, and then, taking 9 from 7, that's, 7 minus 9 is negative 2, so it's 2 in the denominator. So 6 over x to the power 2. Plus, and then 6 minus 9, negative 3. So we're talking about 5 over x to the positive 3. Okay, over And now, again, we're taking out x to the 9. So we're just going to have the 0.000001 left. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. We're taking out x to the 9 minus, and then 16, and then, you know, 8 minus 9, negative 1, so 16 over x. And then plus, and then, yeah, you know, 6 minus 9, negative 3, so 0.00003. 1, 2, 3, 4, 3 over x to the 3. All right, there we go. So there's that. X to the 9 over itself goes away. And what is left? What is left? Limit x approaches infinity. And look here, we have this x term in the top. And now, you know, like we've discussed before a few times now, these terms that I'm writing right now, these guys, these two, are going to go to 0. And we get over 0.000001 minus 16 over x. That's going to go to 0, plus 0.12343 over, that's going to go to 0, okay? So again, we're using this thing in red again, okay? So let's do it, right? Oops. This one goes to 0. This one goes to 0. This one also goes to 0. And this one also goes to 0. And so, what do we have left, right? After that. After that, we have a limit. X approaches infinity of 10,000x over 0.123451. Okay, and now this is going to be a big number. 10,000 over 0.000001. Well, let's think about how many times we move the decimal place to bring it in front of the 1. We'd have to move it 1, 2, 3, 4, 5, 6 times. So 10,000 over this number is going to be the same as this. What I'm doing is I'm multiplying the top and bottom by 10, but I'm doing that 6 times, okay? So if I multiply 10,000 by 10 to the power 6, then essentially what I'm going to get is 10 to the power 10, because here's 10 to the power 4. So, you know, 10, I'll write it this way. 10 to the power 10. 10 to the power 10 with an x over, and then over 1. And, you know, that's it. And so we have x in the top, no x in the bottom, and x itself is going to infinity. We're taking something that's going to infinity and multiplying it by 10 to the power 10, which is like literally 10 billion. And so this obviously will go to infinity. Good. Yeah, so anytime you have, you know, a power of x in the numerator and then just a number in the denominator, you can automatically conclude that that is infinite. So let me write that as well. That's something else that you can use at all times without justification. When you get here, basically that is the justification for this answer. Okay? So let's write it. Yeah? Limit x approaches, and let's be careful. If x approaches positive infinity, and let's say we have, you know, some number times x, or x approaches infinity, it could be some number times x to some power. Okay, and again, we're assuming here that the p is bigger than 0. just like before. And these are going to be either plus or minus infinity, depending on the constant, okay? If this is a negative constant, it's going to be negative infinity. If it's a positive constant, it's going to be positive infinity. So that's something you got to watch out for. But this is something that you can always use. You just got to think about if there's a constant there, if it's going to send you to positive or negative infinity. If you have x to any power on top, and you don't have any x's on the bottom, you can always use this. Okay? Good. Last limit, right? Last limit. Here the degrees are equal. Okay? So, again, if it's multiple choice, immediately, without doing any work, divide the coefficients of the highest power terms. Here's 8, 8. Divide 36 and 4. So 36 over 4, it's like 18 over 2, 9. Yeah, that's the answer. That's the answer. That's all the work you got to do if it's multiple choice. If it's free response, on the other hand, right? We got to factor the highest power of x from the denominator, just like in the other ones. Okay? Factor x to the 8, factor x to the 8. See what's left. I'll have 36, I'm going to go a little quicker with this one, plus 100 over x minus 6 over x squared plus 1 over x cubed minus 1 over x to the fourth, running low on space as always, divided by, and yeah, here we go, right? 4 plus, and then 1,000,000 over x. You know, because we're pulling out 8 x's. 7 minus 8 is negative 1. That means you have 1 x in the denominator. Okay? Now, x to the 8 over itself, that's 1. So we get a limit. X approaches negative infinity of what's remaining, which is 36 plus 100 over x minus 6 over x squared plus 1 over x cubed minus 1 over x to the fourth over, okay, and then 4 plus 1,000,000 over x. Okay? And just like we've done countless times in this video already, we're going to use the same property that we had written over here. Boom, right there in red. Okay? Here, take a guess, right? Goes to 0. Also goes to 0. Also goes to 0. Also goes to 0. Everything goes to 0 here. We have a power. We have x to the 1 in the denominator here, so that's going to go to 0 as well. They all go to 0. What are we left with? Limit x approaches negative infinity. 36 over 4. And 36 over 4, no matter what you do, no matter if you're going in a positive or negative direction, this is going to be positive 9. Okay? So at this point, hopefully you should be equipped to deal with any of these problems that involve a ratio of two polynomials.